You must have observed that in nature many things follow a certain pattern, such as the petals of a sunflower, the holes of a honeycomb, the grains on a maize cob, the spirals on a pineapple, and on a pine cone, etc. And today, in this presentation, we are going to discuss about arithmetic progressions. Let's start. So let me explain this concept with the help of few examples. Consider the following list of numbers: 1, 2, 3, 4, etc. 100, 70, 40, 10, etc. -3, -2, -1, 0, etc. 3, 3, 3, 3, etc. -1.0, -1.5, -2.0, -2.5, etc. Here each of the numbers in the list is called a term. That means 100 is a term, 70 is a term, -2 is a term, 3 is a term, -2.0 is a term. So each and every number in the list is called what? Term. Term of the sequence. First example here is 1, 2, 3, 4 and so on. 1, 2, 3, 4 etc. And we all know that these list of numbers are called what? Natural numbers. The numbers used for counting, that is called what? Natural numbers. And each number is obtained by adding 1 to the preceding number. That means 1 plus 1 gives 2, 2 plus 1 gives 3, and 3 plus 1 gives 4, 4 plus 1 gives 5, and so on. So we can say that each term is obtained by adding the number 1 to the preceding term, except the first term. Okay, so here each term is obtained by adding the number 1 to the preceding term except the first term, because the first term cannot have any previous term. That is why we say like this. And in the second one, 100, 70, 40, 10 and so on. What do you observe? 70 is 30 less than 100. Okay. And 40 is 30 less than 70. And 10 is 30 less than 40. That is 100 minus 30 gives 70. 70 minus 30 gives 40. 40 minus 30 gives 10 and so on. Okay. So here we can say that each term is obtained by subtracting 30 from the preceding term. Subtracting 30 from the preceding term. So it can be stated in another way. 100 minus 30 can be written as 100 plus minus 30. 100 plus minus 30, which also gives 70. And this one 70 plus minus 30, which is equal to 40. And 40 plus minus 30, which gives 10. So here every term is obtained by adding minus 30 to the preceding term except the first term. Okay. Now move to this third one. -3, -2, -1, 0, etc. And clearly -3 plus 1, -3 plus 1 gives what? -2. Then minus 2 plus 1 gives minus 1, and minus 1 plus 1 gives 0, and so on. That means each term is obtained by adding 1 to the previous term except the first term. Okay. And the fourth one, 3, 3, 3, 3, etc. What do you observe? Here each and every term is 3. That means all the terms are alike, same or fixed. So we can say that no number is added to each term. There is no number is added to each term, or in other words we can say that 0 is added to each term. That is 3 plus 0 which gives 3. Again 3 plus 0 which gives 3. 3 plus 0 which gives 3, and so on. So 0 is added to each and every term except the first term. Understood? Then the fifth one is minus 1.0, minus 1.5, minus 2.0, minus 2.5, and so on. Here we can observe that minus 1.0 plus minus 0.5 which gives minus 1.5. The first term minus 1.0 plus minus 0.5, we will get what? Minus 1.5. Again the second term is minus 1.5, then plus minus 0.5 which gives minus 2.0. Minus 2.0 plus minus 0.5, we get minus 2.5, and so on. So here we conclude that the number minus 0.5 is added to the preceding term except the first term. In order to get the list of numbers, we add minus 0.5 to the preceding term except the first term. In all the list above, we see that the successive terms is obtained by adding a fixed number to the preceding terms. Such list of numbers is said to be arithmetic progression, or simply we can write AP. The short form of arithmetic progression is AP. Okay, so we can define arithmetic progression like this. An arithmetic progression is a list of numbers obtained by adding a fixed number to the preceding term except the first term. I repeat, an arithmetic progression is a list of numbers obtained by adding a fixed number to the preceding term except the first term. This fixed number is called common difference of the AP. Common difference. The fixed number is called common difference of the AP, and it is denoted by the letter small letter d. Remember that it can be, that means the common difference can be positive, negative, or 0. In the first and third example, the common difference is 1. First example it's 1, and third example also the common difference is 1. That means it is positive. And in the second and fifth example, the common difference is negative. Here the common difference is minus 30, and in the last one the common difference is minus 0.5. That means negative. And in the fourth one the common difference is what? 0. So it can be 0 also. So one thing you have to remember is the common difference D can be positive, negative, or 0. Okay. So this is a basic introduction about the topic arithmetic progression. Understood? Okay. So the next is general form of an arithmetic progression. General form of an AP. So let first term of an AP be A1, second term A2, third term A3, etc. Nth term, it will be An, and the common difference is D. Then the AP becomes A1, A2, A3, etc. An. A1, A2, A3, etc. An. Now A2 minus A1, which is equal to A3 minus A2. A3 minus A2 is equal to etc. equal to An minus the preceding term is An minus 1. The position is only less than this term. Here it is An, so the previous term is An minus 1. So A2 minus A1 is equal to A3 minus A2 is equal to etc. is equal to An minus An minus 1, and we can denote it by D, the common difference. The difference is common. If we subtract any term from its succeeding term, we get the same number. That is what is called the common difference. That is A2 minus A1, A3 minus A2, A4 minus A3, An minus An minus 1. Okay. Now if the first term A1 is A, then A2 is equal to A plus D. First term plus D is the common difference. As we know, an arithmetic progression is a list of numbers obtained by adding a fixed number to the preceding term. So in order to get the second term, we have to add common difference to the first term, that is A plus D. And A3 is equal to second term plus, that is A2 plus D. Here A2 is A plus D, so A plus D plus D, that is A plus 2D. So the third term is A plus 2D, and the fourth term is third term plus D, that is A3 plus D, and A3 here is A plus 2D, so A plus 2D plus D, which is equal to A plus 3D, and so on. You can see that A plus D, A plus 2D, A plus 3D, etc. This A plus D, A plus 2D, A plus 3D, etc. represents an arithmetic progression. Represents an AP with the first term A as the first term, and common difference D as the common difference. This form is known as the general form of an AP. So the general form of an AP is A plus D, A plus 2D, A plus 3D, etc. Is that clear? Here we have two more definitions: finite AP and infinite AP. Finite AP and infinite AP. Let us consider some examples of AP. 2, 4, 6, 8, 5, 10, 15, 20, 3, 6, 9, 12, etc. 1, 3, 5, 7, etc. Clearly, all the examples listed above forms an AP. And now observe the first two examples. 2, 4, 6, 8. Even natural numbers less than 10. 2, 4, 6, 8 is the set of even natural numbers less than 10. And 5, 10, 15, 20. First 4 multiples of 5. So 5, 10, 15, 20 are the first 4 multiples of 5. So in these two examples, the number of terms in the sequence is countable, finite. That means there are a definite number of elements or terms. These types of APs are called finite AP. That means if an AP contains a finite or countable number of elements, then their APs are called finite AP. Clear? Now look at the last two examples. 3, 6, 9, 12, etc. 3, 6, 9, 12, etc. That means the multiples of 3. And 1, 3, 5, 7, etc. The set of odd natural numbers. The set of odd natural numbers. If you observe these two examples, you can easily identify that the number of terms in the sequence is infinite. 3, 6, 9, 12 and so on. It goes on. The sequence doesn't have an end. So these types of sequence are called infinite sequence. Once again, if an AP contains infinite number of elements, uncountable number of elements, then that APs are called infinite AP. I repeat, an AP which consists of finite number of elements is called finite AP, and an AP which consists of infinite number of elements is called infinite AP. Is that clear? So that's all for today. Hope you understood the concept. If you have any queries, you can ask me in the comment section. Thanks for watching. Have a good day. Namaste.